So back to where we were, vectors today. So we learned from vector that a vector is a quantity represented, I'm just going to quote him, represented, by an arrow with both direction and magnitude. So that he is named that because he commits crimes with both direction and magnitude. Woohoo! Okay, I love that movie. Sorry. All right. So it can be represented by an arrow, but there's other ways we can represent vectors by using coordinates. Okay. So, for example, let's say we have a vector, and we so often put things in the first quadrant. We don't have to do that, but let's do something somewhere else instead. So let's say our vector is in the second quadrant. So there's an arrow representing our vector. So things that are vectors are things like acceleration, velocity. Technically, if you use the word speed, you're just talking about how fast you're going. If you use the word velocity, you're talking about the speed and direction. Okay? So there's different things. Force is a vector. Acceleration is a vector. There's so many different things in physics that you discuss in physics that have both direction and magnitude that are known as vectors. Okay? So doesn't this just look like an angle drawn in standard position? Yeah. Except the angles we draw in standard position, it doesn't matter how long they are. When you're talking about a vector, the length of the vector does matter. Okay? First of all, let's talk about another way to name a vector, or another way to describe it without an arrow. Another way to describe a vector is in what's called component form. The component form of a vector, like vector v, we'll call this vector v. Vectors are either in boldface type, or if you can't really draw boldface type on your paper, you would just put an arrow over the top, because a vector is like a ray, sort of, except the definition of a ray is that it keeps going forever, and a vector does not. So, but this indicates vector v, so we can call this vector v. How does that sound? And the component form of the vector is kind of like a point on a graph, except instead of using parentheses, we use pointy parentheses, which are more like greater than, less than signs. Okay, so our vector starts at one point and ends at another point. If we imagine the vector starting at the point 0, 0 and ending at the point AB, then the component form of our vector would be A, comma, B. Because A would be the vertical or the horizontal component. And what would B be? The vertical component. Okay, so that's another way of describing a vector besides the actual vector itself. Okay? Or another way of doing a vector is actually representative of the picture itself. We can tell about a vector by giving its direction as an angle and its magnitude as a distance. Okay? Direction would be an angle, like that angle right there would be the direction of that vector, right? So, and magnitude is the length of the vector. So in this case, what's the length of our vector? The length of the vector is a hypotenuse of a right triangle. So how would you find magnitude? Well, v is the name of the vector itself. Sorry, that's not really pointing to that side. Magnitude of v would actually be represented by this. Why do you think that has the lines around it? What does that kind of is representative of, sort of? Sort of like an absolute value sort of idea. Because distances, like a magnitude, would always be considered positive. So, anyway, to name the so vector v is an object. Vector v is both the magnitude and the direction. Okay? But if I put the absolute value stuff around it like that, that means we're just talking about the magnitude. Okay, just the size. So how would you find just the size of that vector if you know A and B? Yep. So do you see how when I said earlier we're learning something completely new today, but it's still related? Vectors can be applied to what we've been learning with angles in standard position, with the radius of right triangles that we've been doing SOHCAHTOA stuff with. It all interconnects. All right? Okay. First thing I want to do is just give you some easy stuff. Oh, by the way, first of all, let's actually just give you a little formula for the angle. So if you wanted to actually find the angle, I don't know if I left myself enough space on this little paper here, but the angle can be found if you have A and B. How would the angle be found? It would be related to the inverse tangent of B over A, but then what do you have to do to it? Because that's not the final answer. I should have written these somewhere else where I had more room.
Oh, and then you have to add, you have minus if you want.
It depends on which quadrant it's in. For this particular vector, it would be subtract from 180. For a vector in the first quadrant, that would be the answer. You'd be done. For a vector in third or fourth quadrant, there's different rules for taking the, because really when you're doing that tangent, you're just finding that angle there, and so you have to apply that to the actual direction. It's kind of like you get the reference angle and you have to take the reference angle and change it back to a regular angle. You know how we learned to take angles and turn them into reference angles? We're going vice versa. Okay. Okay, so I don't know if you want me to write that part down somewhere. Would that be helpful, or do you get the general idea since I ran out of room there? Do I need to take the time to write that all out? So then quadrant. Can I just write quadrant? Will that help you remember? You can write down more details than that based on what I explained, right? So those are your main formulas right there for direction and magnitude if you have the horizontal and vertical components A and B. So there's kind of two different things to vectors. There's either the horizontal and vertical components A and B, or there's the direction and magnitude theta and absolute value V. Okay? So you can either talk about a vector in terms of A and B, the horizontal and vertical component, or you can talk about a vector in terms of the direction and magnitude, the angle and the length of the vector. Okay? So two different ways. And then it can also, it can also be represented with a picture. So this would be without a picture, the components. This would be without a picture, the direction and magnitude. And this picture shows both things, right? The picture can show the angle and the magnitude. It can also show the components. So both things can be put on the picture, but it's two different ways to represent a vector. Okay, kind of hammered that in. We're going to talk more about this stuff in more detail in a bit, but first I thought it would be good to go over just some basic scalar and vector operation rules that are super easy. We'll just do the easy stuff first.